We seem to be living in an era of tailored databases. There's been a real explosion of them in recent years. You get databases that are really strong at certain kinds of workloads. Databases designed with a deliberate sweet spot. And I don't think that means the end of the general purpose database, like Postgres or MySQL or anything like that. I don't think they're going anywhere. I think what it means is that as developers, we have to expand our toolbox. We need a larger mental list of the kinds of databases that are out there so that we know when it's time to use the specific tool for the specific job. So, in that spirit, today we're looking at XTDB, which is a bitemporal database. What's a bitemporal database, you ask? Exactly. I've brought in an old colleague of mine, James Henderson, to discuss it. We last worked together years ago, and since then, he's become the lead developer for XT. And I wanted to ask him about the two sides of that job. What's a bitemporal database? Why should we care? And what's it like being the lead developer on a new database? I don't think that's quite like other programming jobs. No, we're all users of databases, but very few of us will be on a project building a database. So this week we get to live vicariously through James, as well as expanding our list of options for future projects. To bitemporal database is kind of something you might have already created an ad hoc version of in the past. But today we're going to see something that's formalized it properly. So let's look at bitemporality. I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is James Henderson. Joining me today, it's James Henderson. James, how's things going?
Hey Chris, doing very well, thanks. And yourself?
Very well, very well. Glad to see you. We used to work together many years ago.
Oh, crikey, it was a long time ago, wasn't it?
Yeah.
It must have been 2013, I want to say.
That's forever in internet years.
Yeah, it really is. It really is.
These days, you are a lead developer for a database called XTDB. Right. And I wanted to talk to you about two things which we have to get deep into. One is, why does the world need a new database? And two, what's it like being a developer on a database? So it's probably best for context we start with what you're building rather than what it's like. So why does the world need a new database, James?
So I'll talk a little bit about what XTDB is. So it's a database. We've been developing it for about 4 or 5 years or so now. It's written in Clojure, and its main sell is that it's a bitemporal database. So it's got time at its very heart. And what we essentially, part of the reason for us building this was that we see so many of our client use cases, we see people trying to roll their own bitemporality, whether it's like sort of tables with soft deletes, or tables with loads and loads of different time columns.
You're going to have to step back and define bitemporality.
I probably am, aren't I? Yes.
Yeah.
So bitemporality quite literally means two times, two time dimensions. Right. They're called valid time and transaction time. The names for those vary hugely across the. So, like for valid time, you might hear application time, business time, domain. As usual in the industry, we can't agree on the names for these things. Yeah. Transaction time is also called system time. So, transaction time or system time is when the system first sees the fact.
Right.
Valid time is when that fact is actually applicable to your business, to your application. So it enables things like retroactive and what we call retroactive and proactive updates. So retroactive being, I understand that someone's changed their name. I've been informed after the fact that they in fact changed their name when they got married last weekend.
Right. Yep. So it's like I'm overdue doing my business expenses. At some point, I will say I bought a laptop last month. Yes, so we'll have the timestamp of now when I actually assert it, and the timestamp of last month when it matters.
Exactly. Yes, right. Exactly that. And then it allows you to ask questions either with or without corrections. So if I'm looking, I mean, one common use case we see, for example, is things like risk and risk calculations and the like.
Right.
And if, as in a lot of regulations, I have to justify why I made a certain business decision or a certain trade or whatever it may be.
Yeah.
One of the things I might say is that in hindsight, that was a terrible decision. It was an absolutely terrible trade. Like, why on earth did you do it? It took you completely out of your risk profile.
Yeah.
But one of the things you can say is actually, based on the information I had at the time, it was a reasonable decision because you go back without the corrections that you've seen later.
Right.
And you
Yeah.
say,
So
what did we know at Tuesday at 4 p.m. without subsequent corrections?
yeah. So only consider it. So you filtering for everything that had happened a month ago, whether or not it was in the future or the past of that in logical business time. Right.
Yes. Yeah.
Okay.
But then in other situations, I might want the exact price as of Tuesday at 4 p.m. as we know it now. Right, because we might have been back and corrected it and said, right, okay, so Microsoft share price was whatever it is. Actually, we made a mistake there, or the system was delayed in getting that information to us. We now know that the price at that time was this. And so now I want the absolute up-to-date information with the corrections as we best know it.
Right. Now, in my dim and distant past, I've worked on accounting systems. And we did that. We had like I forget what the names are, but we had like an insertion time and a business transaction time, right?
Oh, you've added two more to the list there.
I have, haven't I? We're not moving the field forward.
No.
Right, but we did it in an Oracle database, and it was just 2 columns. So I think you have to justify why we need more than 2 columns in our familiar database.
Right, yeah. So the update, especially when you go to bitemporality, the update procedures for that get quite hairy. And especially once you add on those retroactive and proactive updates. So when you've got 4 columns, you as the developer then have to consider, right, okay, so if I am going to make a retroactive update as of 4 p.m. last Tuesday, I need to consider how many rows I need to add, because I'm going to have to add rows to that table, because you're going to have to add rows for essentially the new versions of the document. You're then going to have to consider what changes you make to the existing ones. So I'm going to need to cap off the current row, but also if I'm doing it bitemporally, I'm going to need to cap off the system time. I'm then going to need to keep the record of what it was back then without corrections and the record of what it was back then with corrections. And that ends up being, to maintain full bitemporality, that ends up being quite a headache. The other thing that we bring to this is performance, of course, because if you are just doing columns in your own ad hoc way, the database won't necessarily be able to optimize the queries. So, for example, we put quite a lot of emphasis in making sure that as of now queries, which typically in a lot of systems represent the vast majority of everyday queries, that we make sure as of now queries are correspondingly faster than maybe historical queries might be. So we understand a bit more about the distribution of the data, if you like.
Okay, yeah, that makes sense. Does it factor into like querying as well? Do you have anything like special operators for querying at particular points in time?
We do, yes. So we're basing, at least in sort of XT version 2, the early access that we released a few weeks ago, we're basing that very much on the SQL 2011 spec, which covers an awful lot of ground here for bitemporality.
Really?
Introduces a number of new syntactic structures which aren't very well implemented across the industry as yet. It's taking well, what was it? SQL 2011. What are we now? 2023. It's taken us a while to catch up as an industry.
But the SQL spec, it's not supposed to move fast. Perhaps a bit faster than that, but
yes, quite. So it does allow you, for example, to when you're doing select from a table, it allows you to say from that table for system time as of, and then you can give it a system time. We've then extended that for valid time as well. But you can also do sort of system time between or valid time between. So give me the history of this entity throughout 2022. So between 1st of January and 31st of December. Um,
including corrections.
so corrections depends on what you specify for system time.
Right.
So if I want corrections, I'll leave the system time as of now because I want it to be the most up to date at what
Yeah.
the system knows now. If I don't want corrections, I'll go back in system time.
I can see accountants and auditors loving this.
Absolutely. But the thing is, they've known how to do this for centuries, perhaps. This has
Yeah.
been
Right
their
back to
this
the
has been their
Medici's,
absolute bread
right?
and butter. Yeah.
Yeah.
They've known. I mean, and they've certainly known about immutability.
We need to
The
talk
whole,
about that too.
yeah, this whole thing around we don't ever go back and correct the past. We write a new version. We write a correcting transaction.
Mm.
They've known about that for, let's say, way longer than I've been around.
Yeah. Me too. I'm not that old.
um, yeah, so what we're doing is sort of drawing on that kind of knowledge, which let's say it's about time we did, and especially now that the constraints have changed as well. So certainly in the early days of relational SQL engines, we had very different. We as an industry had very different constraints, and I wasn't around for that either, by the way. We certainly had very, very different constraints in terms of how making best use of our storage. Because storage was very expensive, we had to make updates in place in order for it to not become crazy expensive.
Yeah.
Whereas now, with storage, especially remote storage, being a lot cheaper and a lot faster to access, the sorts of solutions we can consider for these kind of databases, where all of a sudden it does become an option to store literally everything, to store your entire history.
Yeah. Yeah. There was a period in our history where you would update and throw away old financial data because you had 64 meg of RAM,
Yeah,
right? And it was
yeah,
your
no,
only,
exactly.
or sometimes like 64 meg of disk if we're really going back. So you
Yes,
had
yeah,
to. Yeah. We can make different design decisions now.
absolutely. And we can, I mean, obviously, we still prioritize keeping as much data as local as we can. So we'll in XT we're looking to bring as much data sort of into CPU cache, into memory, into disk, into something like Redis, and then only at the last stage do we go all the way out to the remote storage.
Yeah.
Again, I think that's a fairly typical pattern anyway. We're not inventing anything new there.
Okay, so
In the tier caching world.
you're leading into some gory details, which I want to get into. What's happening under the hood? Give me some technical facts about how you make this work.
So XT, both in the version 1 that's out in production at the moment,
Mm.
and the V2 that we're on the early access. It's based on what's called the inside out architecture, which I first heard from a talk by Martin Kleppmann. Apologies if that may well not, he may well not be the first person to have thought of it.
He's,
But
I think, I don't know either, but he's widely recognized as giving the founding conference talk that made everybody start talking about it, right?
yes, yeah.
Yeah.
And the inside out architecture says that rather than having the log sort of ingrained within the database and being an internal implementation detail, we make it front and center.
Mm.
We very much have the log as the history of everything that's happened, and then base our data store on that log, as like a projection over. So your data becomes essentially a projection over that log,
Yeah.
and that's sort of the event sourcing folks will find that very familiar, no doubt.
Yeah. Yeah.
So
As you
XT hasn't
might
really
know,
got into the event sourcing space yet,
yeah.
but they'll certainly be very familiar with that.
This is
So for
related to like
us,
Kafka, right?
yes, no, exactly.
Mm.
Yeah, definitely related to Kafka, and in fact, Kafka is our model for what we call the transaction log within XT.
When you say the
So
model, as
XT's
in you've copied it, or it's like you use it? Which one?
so the model implementation, the better implementation of the transaction logs.
Right. Okay.
So XT is more so in V1 is what we call unbundled. So you can bring certain components to the table. We ask you to provide a transaction log and an object store. So a transaction log has to be totally ordered, and all of the clients all of the consumers have to agree on the order of the transactions. That's what gives us the consistency over the cluster.
Right.
But then we also have a component called the object store, which, as it sounds, is if you think S3 or blob storage or whatever Google Cloud call it. It's called cloud storage, isn't it? Whichever sort of whichever cloud you subscribe to.
Yeah.
Other other services may be available. So it's that kind of principle. Where for object storage, we're looking at being able to store big blobs of data and grab hold of them as necessary.
Okay, so you also like storing images, movies, that kind of thing. Happily enough.
No, so the blobs is for it's essentially our database pages. If you think a database page in your file,
right.
And then it's up to us to then manage that, which pages we bring locally and which pages have to stay on the remote. So the idea behind that is that we as XT don't then manage that. So we delegate a lot of the hard work to that.
Yeah.
Particularly Kafka and the total ordering and consistency between clients.
Out of curiosity, what are you totally ordering by? Which of your fields?
So we're totally ordering essentially by transaction time. So it's a single writer, similar to Datomic's idea.
Okay, so single writer, single partition on Kafka, and you're just building this big append-only log.
That's exactly right.
Right.
Yeah.
Okay. Yeah.
Yeah. That's what that's. So yeah, no consideration about partitions at least as yet.
And so you say you're offloading a lot of the hard work, but it sounds every database contains part of an operating system, right? And you're managing a page cache to disk. That's getting it close into like what operating systems do to manage levels of caching.
Mm-hmm.
That must be a laugh.
It's quite naive as it stands.
Okay.
We've got a lot of work to do in that area before we can really sort of push V2 out to the big time.
Okay. So is this largely considered to be like an analytics database rather than a transactional database?
We're calling it HTAP, so hybrid transaction analytical.
Okay.
So the idea being there that way too much time in our industry is spent in ETL land, and if we can get something that works reasonably enough for both, we'll be in a good shape, and we can get people building applications on top of this,
right?
Without having to go through a lot of that rigmarole.
Okay,
so certainly there's a few of the technology choices we've made that are slightly sort of oriented towards the OLAP side. And we're having to make the OLTP side catch up a little bit at the moment. That's indeed what I was working on before I came on this podcast. How do we make that happen?
That gets into it. What's it like being, because lots of us build like web apps, right? A lot of programmers are out there building some kind of application that faces eventually some kind of non-technical user. Mm-hmm. And then excuse me, you're working on like really core infrastructure that will eventually be used by developers to eventually do something for people that aren't technical at all. So what's it like?
It's quite different. And certainly for me, at least, it took a while to get used to. I think so. For me, sort of, I mean, the vast majority of my experience has been in exactly that. It has been sort of web apps. It's been in like talking to end users. And you're familiar, and chances are most people listening be familiar with the kinds of processes that go on there, the kinds of cadences you get into when you're developing, in terms of sort of milestones and releasing functionality and that kind of thing. There's a couple of things that are quite different about databases, and obviously for us it's very much more about R&D. So I think one of the big differences we see there is that we have very few estimates in our planning processes, largely because of the R&D nature of the work, and especially in this last 18 months or so, when we've been very much in a research phase. We're also focused a lot more on backwards compatibility. Like I've in the sort of my early days of Clojure, I wrote a few libraries for the Clojure ecosystem. And there, in library world, you have to worry a lot more about backwards compatibility than you do in web
Yeah.
app world. And in database world, it's worse.
Yeah. Yeah, I can believe. You've got to worry about not changing APIs, and they've already got this log of immutable data.
Yes. Yeah. No. Exactly.
Yeah.
And so there have been quite a few issues in XT, certainly in the early days, where we really had to consider, right, what have people got serialized on disk?
Yeah.
And particularly when you're in the immutable world,
Hmm.
when we're saying that this transaction log is completely immutable, we're never going to go back and change that log. Like whatever structures are on there, and they're and short of a migrate your entire log,
Yeah.
which we've been tempted by once or twice,
All
but
right.
have never done it. Merely because we understand what impact that would have on our users.
Yeah.
You've got a live running system. What you really don't want is your database, like your database folks saying, right, so what you're going to need to do now is to stop everything.
Yeah.
Pipe your log into something else, pipe your transaction log into something else, and then go again.
Which ideally, I mean, if things are working the way they're supposed to, is a really large, important log of like
Yeah.
possibly financial data.
Yes.
Yeah. Yeah.
Yeah. Exactly that.
So
Exactly
how do you
that.
deal with that? I mean, it sounds like your hands are very much tied. How do you make progress?
Generally by being quite conservative about what we put on there in the first place.
Right.
There have been a few features certainly that we've considered and have had to step away from because of not wanting to change that transaction log, but also partly because we when we read that transaction log, we then index it in a form that's more useful to us. Obviously, you don't want to be playing through a transaction log every time. You need to make a can you find me the order with this ID query.
Right.
So we pull all the transaction data off there and index it. And in version 1, it's all local. In version 2, it's a bit more shared between the different nodes. But that gives us an opportunity then to say, right, okay, if we really do need to make bigger changes, that's our chance to in a reasonably backwards compatible way say, right, okay, what we're going to do, we're going to change our indexing structure. And so while your system is running live on like version n-1, your system can carry on going, and we'll index it into that format. But you can bring up another XT node with a new version. Once that's caught up with the indexing structure in the new format, you can then sort them over in a sort of green blue deploy type way.
Right. Yeah.
But that's a great thing we get out of this inside out architecture, and we couldn't do that if the log wasn't the absolute golden store
Yeah. Yeah.
of
And
the
it's also
data that
nice
goes
that
into
you've got
that
like
goes to XT.
with an immutable log, most of the data's just sitting there guaranteed unchanging, and there's just a new bit at the front to worry about. So
Yes, yeah,
I imagine if it's anything like Kafka World, you can do those re-indexing upgrades and do nearly all the work as slowly as you like.
yeah,
Yeah,
yeah. No,
which must
exactly
make it
that.
easier. Yeah, okay. This makes me want to circle round a bit to, you say indexes, makes me think, what's it like as a developer using this database? Is it like a relational database and I'm creating my own custom indexes and stuff like that? What's it like to work with?
So XT is a very much a schemaless database.
Okay.
So we don't require any upfront schema from a user. And so even though it supports now both Datalog and SQL, we don't have to do any of the sort of the usual SQL DDL of create table or anything like that.
Oh, okay.
You're not restricted on what columns you put into a table. Essentially, you insert a document, you insert a map of data. The only thing we do ask for is an ID, like give us an entity ID, and
Right.
we'll work with that. That just gives us that gives us the ability to keep track of an entity's changes over time, because the ID remains constant.
Yeah.
So it's quite free and flexible in that regard. And then we then do the best job we can with our indexes to get you the data you need. So we keep a number of different trees, a number of different trees. I say this at the moment. It's in rocks. So
RocksDB. Okay.
RocksDB, yeah,
Yeah.
and that's great at storing sort of ordered trees, and that gets us pretty decent performance.
Okay.
But we're looking at different structures for V2. V2 is a columnar database based on Apache Arrow, which
Oh,
has
okay.
a completely different way of thinking about how we're storing the data, and also again coming back to what we were talking about earlier, the constraints are a little bit different. Like all of a sudden, the cost of scanning a lot of data on disk comes down relative to sort of random accesses, and so our query engine now is prioritizing those over a lot of random accesses in some cases.
So for version 2, you've had to rewrite the query engine on top of everything else.
Yes, yeah.
That in itself is a lot of work. I mean, I'm just thinking of Oracle.
Yeah,
That's like it's almost like a historical empire of optimizer code, right?
it's certainly a lot of optimizer code. Like if you, we we were looking around once at the various job boards when we were looking to hire for XT, and you look at the job boards for database engineers, and they are nearly all you'll be working on query optimization. By far and away the biggest the biggest thing people are looking for in the
Really?
database world. Yeah,
I'm surprised. I mean, I know it's big, but I wouldn't have thought it's like significantly the number one thing.
it certainly seemed to be in our very limited research.
Right. Okay.
Yeah, yeah, definitely. Um,
Okay. So I'm trying to think this through now. So inserting documents, right?
mhm.
Have you got this? Is it like if? Let me put it this way. I create a user by inserting a new user document, and it's got like their name and their age and their social security number and their address. Now I come back and I want to change their address. Can I just insert the delta, or do I have to reinsert the whole record?
So you can now. So we do have SQL's update DML, and what we're essentially doing then on your behalf is grabbing the document and creating a new version of that document.
Oh, okay, so under the hood, you're writing a whole new. You're like Git, right,
Yeah.
where it stores the complete version of the file every time.
Yes. Yeah.
Okay, that must be mixed because you've got a single writer. So you've then got
Mhm.
the kind of operating system problem of managing access to that single writer.
So the operating system we get that for free with the SQL partition from Kafka. So we don't have to do an awful lot of coordination. We don't have to do any coordination between any threads or anything like that, or any sort of
Okay,
concurrent processes. And for a lot of use cases, that's absolutely fine.
okay. Well, let's
Like
talk
a
about the
single
other
partition
side.
on Kafka can be very quick these days.
Yeah, and very large and still be
Mm.
useful. All right, yeah.
Yes, yeah.
Let's look at this from the other side then. There you are optimizing different queries, worrying about not changing data. How do you get meaningful data sets to test against for a new database?
So there are a few industry benchmarks out there
Okay.
that we use. The main two that we tend to look at when we're doing sort of, when we're looking at the impact of new changes is TPCH, which is quite a common industry code.
TPCH.
So TPC is the Performance Consortium. They've got benchmarks like A through whatever.
Okay.
I've got no idea how far they've got these days. But H is an OLAP benchmark,
Okay.
and it's based around a fairly typical use case of customers, orders, products, line items, suppliers, and pretty much any if you were running a business of that kind of nature, it's all of the analytical and BI like queries that you can imagine.
Oh, okay.
And you can run that at different scale factors. So, for example, we run it at quite a small scale factor to have a rough idea of the impact of a change. But then you can scale it up and run it on a larger scale factor Like, for example, when you're doing a new release or you're really looking at a change that's going to heavily affect performance at larger scales.
Okay, that's
Um,
interesting.
but,
As
but
someone who
there's also
builds
similar
demos,
OLTP benchmarks as well.
right? Yeah, as someone who builds demos, having access to a data set like that, I shall store that away mentally for future
Yes.
projects. You
um,
mentioned the word of the industry, scale.
mm-hmm,
What's the scaling story? You're a single writer, so you're
mm-hmm,
limited on writes. What's your scaling for reads?
yeah. So the scaling on reads is that you can scale reads horizontally. So if you do need more read scaling, then you add a new XT node. It brings itself up, and then you start querying against the shared object store in V2. So it will pull down what it needs from the shared object store and then get going.
Oh, okay.
Now, because our transactions are entirely deterministic, we know that the state on each of the nodes is going to be consistent, and that's a big simplification for us. Like we don't need any coordination or anything like that between the nodes because we trust that they're going to end up at the same state at the end.
Oh, right. They may not necessarily be in sync, though, perfectly.
They may not be in sync. So what you have to do in that case is that each again I'm talking the V2 here. Each client keeps track of the last transaction that it wrote, and at the very least, it will give you that the world as of that transaction. So
Oh,
that
okay.
enables you to read your rights.
Yeah.
If it's got further than that, that's great.
Yeah.
But yeah,
Yeah.
you can at least put a document into the database, and then the next query you make will read it out.
So you have been thinking like my university professor is going to be very unhappy with me, but the name for those like isolation levels in database design.
Yes, yeah.
Okay. That must be
Uh,
fun.
so in that case, I mean, the single writer again gets us a long way here. So in terms of and because the reads and the writes are separated, on the right side of things, you obviously submit the transaction to Kafka. It comes back round through the Kafka pipeline. But then because you've got the single writer at the head of the queue, we actually work at a strict serializable level, which is the top level that you can get on the writer side.
Yeah.
Like
Yeah.
every transaction is guaranteed to see every transaction before it. So it's naturally serializable because it's a single writer.
Yeah. Things get a lot easier when you don't have concurrent writes.
Absolutely, yeah.
Okay.
But you think about the amount of locking code that we also don't have to consider either.
Yeah. Yeah.
Like
Yeah.
row locking, and that isn't a thing. Um, uh, we don't at least as yet have interactive transactions, so it's not like you can then read and then write based on that read. So you don't get sort of you don't get people accidentally locking a table or anything like that with it. Don't get any of that kind of stuff.
This is the thing I've thought, like, off the back of Martin Kleppmann again. If you start with this transaction log, then you're basically
Yes, yeah,
building state machines on top of that transaction log.
you are. Yeah.
And like a SQL database like Postgres or Oracle is a really, really clever, fancy state machine
Mm-hmm.
to allow these things. But do we need as sophisticated a state machine as that for all our transaction log processing tasks?
A very good question. I mean, I think we're obviously a little bit biased. We're we're obviously quite biased on that one.
So, do you ever get like different people using the same transaction log that you're using for your bitemporal view of it? Do people reuse that same underlying transaction log for different purposes ever?
I'm not aware of people using our transaction log. I mean, the format on there, while it's an open format, is probably a little bit gnarly for people to be
Okay, fair enough.
reading off
Very
correctly.
honest.
I think with actually no, I'll tell a lie. I'll tell you what, because as part of we provide it, so it's a half lie. We provide a Lucene module for XT that reads off the same transaction log. And there are internal APIs if people do want to go diving down that do give them that access to the events coming through the system.
Okay. What's the Lucene API get used for? I mean, what do people set? It's just like free text search in your transactions.
Yes, yeah, no, exactly that.
Okay.
So yeah, if you're yeah, I mean, I think all the usual use cases for Lucene really. Where we do have the opposite, in fact, where we do have the ability to hook XT into someone else's transaction log, and we've done this. We did this for a client who were using Corda, the Corda blockchain. So
Oh, yeah.
they had a see the B word came up.
Yeah.
Um,
I can see why they want. I mean, they've got a mutable log, and they probably need
yep.
analytics on it. Yeah, I can see this.
So they already have the data in that format. What they want is a way to query that
Yeah.
using XT's bitemporality. And so we wrote them a little module that hooked the two together. And so they kept their core a source of truth, but they were able to then run XT queries over it.
Ooh, I can see that being really popular in the blockchain world.
Ah,
Without
yeah.
without without declaring for or against blockchain technologies, I can
Mm-hmm.
see decent analysis over those blockchains as a service being quite popular.
Right. Yes. Yeah. Well, I guess it's the same principle, isn't it? It's a log at the heart of the system,
Yeah, yeah.
and
So
so yeah, there's quite I can see quite a lot of overlap there.
that takes us to the question, the $64,000 question for a small company building a database. Who's using it and for what?
So we're seeing quite a lot of users across various different industries. Obviously, we see quite a lot of it in financial industries, as we were talking about earlier.
Mm,
I think the kind of the natural tendencies in that industry, both to know whatever happened at a certain time, and especially with the kinds of regulations that are coming through, that are really forcing people to justify what they knew and when,
yeah.
and that kind of thing. So we see an awful lot of usage in those kind of areas. But to be honest, it varies. It varies quite widely. Um, like anything where like time is of the essence, if you like. Um,
Mm.
so we see, for example, in pricing systems, in product pricing systems. In one case in particular that Juxta's worked on with quite closely, we've the company like to schedule price changes, and they can do that with a
Ah,
bitemporal system because you can say I want this product to have this price as of next Tuesday.
yes. Yeah.
So any kind of
And
scheduling or CMS or those kind of systems use the other side of bitemporality, if you like.
yeah, writing into the future, which is a largely unexplored field, right?
Yes, yeah, yeah.
Yeah. Does it is that reliable? Is the developer experience such that you're not going to accidentally write software that pulls from the future?
In what way? Sorry.
I'm just thinking like you've got all this flexibility to make that query. How
Hmm.
easy is it to ensure that you do the right thing in most cases?
So our defaults make sure that the default is always as of now. So you only ever see us if you can imagine a nice big sort of 2D graph of sort of history going through in both dimensions. We limit you to the y equals x, the diagonal, by default.
This is an audio podcast, right? Well, yeah, okay.
So you
I
can't
think
see me waving my hands and sort of hand wavy explanation of any of
the
this.
people listening to this on like Spotify and Apple Podcasts can't even see your resplendent beard, James.
Oh, they're missing out. They're missing
They
out.
really are.
Yeah. So in which case, so without the visual metaphor, then I say in a lot of cases because it's what sort of traditional relational SQL databases do.
Mm,
We make sure that the default is as of now.
right,
Both in what we currently know and what we currently know about the current time.
right.
So
Yeah.
transaction time and valid time. you have to explicitly ask for across-time queries.
That's what I was getting at. So the default behavior matches your expectations of how things generally work.
Yes.
Principle of least surprise, they call it.
Absolutely.
Yeah.
Absolutely.
Okay, so I think I have two more big questions to ask you, and I think they're slightly controversial,
All right.
but I have to ask them.
Buckling up.
Why build a database in Clojure?
So I think for us, Juxt is a Clojure company, and we're very much sold on the on the ideas behind Clojure, especially as so building an immutable schemaless dynamic database seem to go quite hand in hand with an immutable schemaless dynamic language.
Yeah.
So for us, it was a good fit in that sense. We've also obviously got quite a lot of experience with the Clojure industry as well. So there was quite a good pairing there. We do, of course, find that the more sort of the more performant areas of the code, we do find, and especially the more sort of stateful, mutable, ugly code that you tend to want to hide away.
Yeah.
That is being written more and more in Java now.
Okay.
Just because there were certain areas where we found that we were writing Clojure as if it were Java for the mutable performance. But this is as our Lord and Savior Rich says, Rich Hickey.
Rich Hickey, creator of Clojure.
Yes, he says it's. I think he's done a couple of talks now where he said that so long as the exterior of the system looks immutable and behaves immutably, what you do below the surface, if the tree is being mutably hacked down in the forest, so long as the exterior behaves immutably and gives you those guarantees, that's okay.
Okay, so you're happily in Clojure in the logical world, but under the covers,
Yeah.
I don't want to say slumming it with Java. You're I can't think of the right way to say it that isn't going to offend someone, so I'll just drop it.
Hey, it's getting better these days. It
really
is getting
is,
better
yeah.
these days.
Yeah,
Like they've learned a lot from the JVM languages.
I think they got a bit, I don't want to say complacent, but what they lost momentum in the
Yes, yeah, I think
Java
that's very
world,
fair.
and then suddenly maybe Clojure, definitely Scala, and maybe even
Kotlin
Groovy.
since then.
Kotlin since then made them get their act together, and that's very hard to go from a language that's lost momentum to getting it back again. But hat tip to
Yes,
them, they
yeah,
really have.
yeah, definitely.
Okay.
I think the other thing I'd say about Clojure is, especially for a research project, we find we've been able to move a lot quicker. So if you think about the sort of the make it work, make it pretty, make it fast, certainly for the make it work, we found that we've been able to do that phase very much quicker from Clojure and its interactive development. The REPL experience and the fast turnaround times. So the experimentation side of things, like what happens if I design a system in this way.
Clojure can be a great language when you have no idea what you're doing, which happens in programming, right?
Absolutely. And it happens just as much when you're writing a database as it does when you're writing a web app. Maybe more so.
I can believe. Because you're especially if you're writing a new database where you're having to explore entirely new design decisions.
Yes, yeah, definitely. And I mean, for us, at least in the early days when we were figuring out how to best use Apache Array, having something that we could really sort of poke it with and see what it did. You have to be quite. It's quite strict with you about your memory management in Apache Array. It's very sort of manual memory management type.
This is an aside that maybe we'll save for the DVD bonus features, but tell me a bit more about Apache Array.
So it's a columnar data format. It's been pioneered by Apache and being used in a number of different companies in industry. But one of its main benefits is that the on disk format is exactly the same as the in-memory format. So there's no serialization or deserialization. If you want to, for example, read an array file, a memory map is a great way to do that.
Okay.
because there's no say for example you were writing your files in JSON or whatever have you, that you'd need to translate that into whatever objects that you've got, whatever objects that you're working with, or maps if you're in the closure world.
Yeah.
Whereas with Arrow, there's none of that translation happening. So you're literally reading bytes.
And what are you
Working
getting
with
back?
bytes.
Like, do you spend a lot of your development time deserializing byte strings, or is it just pop off disk looking like a closure map because that's what you wrote?
Certainly for the primitives, so it'll pop off disk looking like doubles and longs and
Okay.
that kind of thing. Maps and other composite structures, maps and lists predominantly in Arrow, are stored in a columnar way. So, for example, when you've got a map of like A and B keys, the Arrow format will store all the A's in a row. All the A's in a column, and then all the B's in a column. And so you end up, particularly if those are fixed width, so particularly if they are sort of longs or doubles or the like, you end up being able to navigate like straight to the value you're looking for.
Okay, and that, I'm guessing, that works out super fast if you want specific fields or you want to aggregate specific fields. But the trade-off is you lose getting the whole object with all of its fields quite so
Yes, yeah.
quickly.
And we've had to put a little bit of thought into how we do things like select star for that exact reason. Yeah.
Okay. So last controversial choice. I know XTDB supports two different query languages.
It does, yes.
Tell me about that.
So from the early days of XT, we very much went with Datalog. Again, heavily inspired by Datomic. I don't think that's any secret. And I think for us in the closure industry, I think there's always been a little bit of that love for Datalog. It's very much sort of a data-oriented query language. It feels a lot more sort of declarative in the way that you're asking for what you want rather than necessarily how you want it.
For those that don't know, because I've worked a little bit with Datalog, but for those that don't know, describe it.
So Datalog is essentially is a language that works. It's a logical language. It's a subset of Prolog. Although I guess if people haven't worked with Datalog, then I'm going to work with Prolog. But where essentially you bind different variables to values coming out of your documents. So, for example, if I'm joining customers onto orders, I'll make two declarations. I'll say that a customer has a customer ID of my customer ID, and then I'll say that my order also has a customer ID of that order ID. And what the Datalog engine is then doing is saying, right, okay, I can see customer ID twice here. I'm going to unify these two, and that essentially is an implicit join.
Right.
And so you can trade. You can very much sort of within your query, you can very much see, right, okay, so here are the things that I need. Here are the things that I'm joining on, and I get a bit more of a declaration of sort of when I traverse my graph, if you like, because you can kind of think of customers' orders line items as a bit of a graph database, and at times we have called XT a graph database.
Oh, have you?
For that very reason, yeah, because you can think about it in a graph-like way, a graph of documents. Where was I going with that? So yeah, when you're writing the query, you are writing it almost like a graph traversal. You're saying, right, find me this customer node, and then from this customer node, navigate out to the order node, and navigate from the order to its individual line items. And the query actually looks like that to work with.
My experience
but fundamentally, it's data as well. So it's data rather than a string. So anyone ever worked with a SQL has probably had to generate SQL at some point in the past. And has sort of got in a bit of a tangle about how many ands do I need in my where clause when I'm
yeah.
You've been there, you know what I mean.
You can't really. My favorite feature of Datalog is you can start, because it's a data structure rather than a string. You can start to compose things, right?
You
can say, here's two extra clauses that I want to mix in with this query.
Yeah, exactly.
Without having to like string edit where the and is in my where clause.
and all of the SQL injection that follows, no doubt.
Oh yeah.
Um, but what we've done recently, so we obviously love Clojure, and I think we obviously love Datalog, and I think the Clojure industry obviously loves Datalog as well. But we've recognised that love's not universal.
How aware of you?
We recognise that it's a hell of a niche, and that you're not going to get, even if you, the development team, are fully bought into this. You're not going to convince people outside of that that they should cast aside all of their SQL experience and tooling and everything else that they've gotten used to about the SQL world. So that's one of the reasons why we really wanted to make SQL a first-class citizen as well. And so what we've ended up building is a database where you can query the same data with both Datalog and SQL. And roughly equivalent Datalog and SQL as well. So you can look at a Datalog query and a SQL query side by side, assess that they're equivalent queries, and they'll return you the same data. They'll return you the same results. So we think that's fantastically powerful.
Are they on feature parity? Is one more powerful than the other?
They're not far off, So we've had to put a fair bit more work into SQL. Datalog, particularly in terms of its scoping rules, is quite a lot of a simpler language. But what we do is we compile both of them down to an intermediate representation. We compile both of them down to what we call a logical plan.
Right.
Which is essentially relational algebra, that old thing.
Your university professor must be very proud of you.
Oh yes, yeah. Might not have been proud of how much I remembered when I first started on it, but at least the remembering that it existed was certainly a very good start.
Yeah.
But isn't that all we're ever doing? So remembering that something exists enough to go Google it.
Yeah, sometimes the hardest problem is discovering the bits that you don't know. That's why this podcast exists. There's my plug.
But no, relational algebra is fantastic. I love it, and I mean it's obviously the underpinnings of SQL. So SQL is very much based on that. But the composability of relational algebra, like you really can compose those queries together, and we're looking to get back to that with Datalog.
So you're hoping secretly that those people that start off with SQL will gradually be tempted to your way of doing things?
You can cut that out of the podcast, right? Don't tell anyone.
Yeah. Yeah, we'll leave that on the cutting room floor, honest.
Yeah, okay.
If you're hearing this at home, I have betrayed James and he's never speaking to me again.
No, I mean, to be honest, I mean, it very much was the tooling of the SQL ecosystem, because there's just so much of it. Like with the best will in the world, we're not gonna compete with that in the Clojure industry.
Yeah, I'm inclined to think that if you're trying to do a new way of doing databases, that is one front on which to change the world, and that's plenty.
Yes.
Yeah.
Yeah, you have to be a little bit sort of conservative about that particular budget, don't you? I mean.
Yeah, absolutely. Yeah. So you said,
what's the phrase? Is it Datalog rocks, but SQL reaches?
Datalog rocks, but SQL reaches. Love it.
So to steal a phrase there.
I can predict that at some point in the future, your team will have that on a T-shirt at a conference, giving it away.
Absolutely, yeah.
Yeah. So you said you've just put version 2 in, was it preview release or early access?
It's very much early access at the moment. So we're in listening mode. So John, our CEO, announced the V2 early access at ClojureConch, which is a few weeks ago over in North Carolina.
Mm-hmm.
And so the idea behind this is to get people to have a bit of a play with it, try it out, let us know what you think, and let us know of any big stumbling blocks you come across. Over time, we'll be moving through the traditional sort of alpha, beta, RC, and stable release.
Okay.
So I think it's fair to call it pre-alpha right now. If you're not comfortable with the bleeding edge, it's probably not for you just yet.
But where do I go? Is it fun to play with if I want to just kick the tire as an experiment?
Absolutely. So you can go to xtdb.com/v2, and all the instructions about how to get started and write your bitemporal queries will be on there.
Okay, I'm going to give it a go. It sounds like fun. And
Great.
maybe I'll finally get the accounting system that will make my taxes easy at the end of the year.
You've got to write all the tax rules yourself, though. We don't bundle those in.
I hear the government's going to simplify them any day now. I won't worry.
Yeah, I'm sure.
James, as ever, a pleasure to talk to you.
And you, good sir, and you.
Good luck with the path to official final release of version 2.
Cheers, Chris.
Cheers. Thank you, James. If you'd like to take XTDB for a test drive, if you want to explore bitemporality or data log or anything like that, there's a link to the project in the show notes. And if you do, please drop them a line if you've got any feedback. I know James would appreciate it. I appreciate feedback too. So if you've enjoyed this episode, please take a moment to like it or rate it or share it or review it or subscribe to it, or all those different feedbacky things. It always helps and it's always interesting to hear. Or just drop me a line. My contact details are in the show notes too, for Twitter and LinkedIn and the usual. And while I'm thinking about it, we're going to continue to explore different kinds of database on this podcast. So if you've got any suggestions or requests, let me know. I know I'm planning to do vector databases soon. That one interests me, so that will be coming up. But I think that's all for this week. So I've been your host, Chris Jenkins. This has been Developer Voices with James Henderson. Thanks for listening.